Welcome to multiple choice question 18 of the 2007 Mathematical Methods Exam 2. In this video we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. And now before we move on to the problem, I'd just like to point out that the use of a CAS calculator is the most efficient way in answering this question. In fact, it's the only way that we can answer it. So for question 18 it says the heights of children in the queue for an amusement park ride are normally distributed with a mean of 130 centimeters and a standard deviation of 2.7 centimeters. 35% of the children are not allowed to go on the ride because they are too short. The question then asks that the minimum acceptable height correct to the nearest centimeter is one of the following options. So whenever we have a question like this that involves a normal distribution, I'd recommend just drawing out a bell-shaped curve to help annotate what's going on. So I'm going to use a computer to generate a nice looking one for us. And we're going to say that x is the random variable, which is normally distributed with a mean height of 130 and a standard deviation of 2.7, so a variance of 2.7 squared in that notation. We knew that 35% of the children were too short, so that refers to the left tail because being too short is a smaller height. So we know that the area of this region that I'm just shading in here, this must be 0.35. And I'm just going to say that there's some value A here, which is the minimum acceptable height. So in other words, we want to find the probability that x is less than a is equal to 0.35. And that's something that we'll need the calculator to help with. On the CAS calculator, go into the main menu. Next, we can identify from the question that it's an x value that we really need to calculate for this, rather than a probability, because the probability is given. So that means if we go interactive distribution, we actually want to use an inverse distribution, and this time it's the inverse norm CDF, where being too short will be in the left tail, all right, so the heights are smaller there, the x values are smaller in the left tail. We want the probability to be 0.35, and then we know that the standard deviation of this particular question was 2.7, and that the mean height was 130. So hitting OK, this gives us 128.95 or 96, which we'll round up to an integer anyway, and that will tell us the minimum acceptable height. So from the calculator, we found that A must equal 128.96 to 2 decimal places, which means the minimum acceptable height when rounded to the nearest centimeter is 129 centimeters, which makes option D correct for this question. So from the examiner's report, we can see that this question was done reasonably well, with 71% of students getting this question correct.